Hello everyone, this is Bandgar SS working as assistant professor at Department of Physics at HM College, Nasa. Today we have to going to discuss M.Sc second year semester 3 paper 3 experimental technique in physics first. Today we have to going to discuss the topic of signal analysis and sense, and we have to cover up the subtopic of signal analysis. So starting with a concept of reliability chi-square. So what is the chi-square text? So it is the used for to the calculate the accurate value from a repeated measure. So when a set of measurement is obtained, then chi-square test compare expected measurement value to the observed measurement value. So it is compare measurement value and expected measurement value and observed measurement value. The chi-square parameter is quite useful in statistical analysis of data as it helps to test a particular hypothesis in the given data. So chi-square it is the one statistical analysis tool which helps to use the particular hypothesis present in a given data. It is also to determine whether the observed frequency and expected frequency are close enough for us to conclude that they come from the same probability distribution. So observed frequency and expected frequency are very close to each other and conclude that they come from the same probability distribution, like the normal distribution or distribution. So we have to conclude. So the equation of chi-square test is chi-square is equal to summation of I is equal to n is observed frequency minus expected frequency, that is the difference between two, that bracket square upon expected frequency. So you will get the chi-square of that event. So reliability chi-square test is used for the data used in calculating chi-square statistics must be a random raw, mutually exclusive, drawn from the independent variable and drawn from a large enough sample. Example, a tossing of fair coin meet, so you will get the that thing. So it is a randomly raw data mutually exclusive, drawn from independent variables, drawn from large enough samples. So chi-square it depends on the size of difference between actual and observed and the degree of freedoms and samples. So chi-square is dependent on three parameters: difference between expected and observed values, degree of freedoms, and sample size. Is the degree of freedom. So how to number ways you have to perform that. You have to perform that experiment. Number of degree of freedom is 2. Then you have to calculate variance and deviation distribution of probabilities or statistics. If number of degree of freedom is more than 2, then we have to calculate mean and normal distribution. Now the test can be used in goodness of field of distribution, that is normal and Gaussian. So second one is the test the independence of the attributes and test the homogeneity. So these the three factors are checking that using a chi-square test. Now when we get the number of observation or when we take the repeated of measurement, so we have to require analysis of that data, repeated measurement. So we have to use some statistical tools. So analysis of repeated of measurement is done by various statistical tools. First one is the basic tools. First one is the mean, the average of a set of data. So it is the average of whatever data you have taken. Second is the variance. Variance is the defined as sum of the squared deviation from the mean divided by n minus 1. So there is the summation of the squared deviation from the mean. So number of observation is, so next tool, statistical tool, is the standard deviation. This is the most commonly used for measure the spread or dispersion of the data around the mean. The standard deviation is defined as square root. So standard deviation you have to easily calculate by variance, or variance easily calculated by mean. So it is the independent to each other. So we have to know the mean and variance. So you have to calculate easily standard deviation. If you have to know the mean, so you have to calculate easily. Now, second statistical tools for analysis of repeated measurement is the convenient tools. So first test is the M-test, that is the Fisher's test. It is the comparison of the spread of sets of data to test if sets belongs to the same population. In other words, if the precision are similar for this. So M-test is compare the two data groups or two data sets from the same population. So there is the precision is no matter, calculate M-test. Now second T-test is depending on the nature of two sets of the data. The means of the sets can be compared or bias of several variants of the test. So using the mean of the two sets, we have to compare and calculate the T-test. Now third one is the linear correlation and regression. So it is also related by the compare to the two sets, that is the correlation and regression. So this most two common useful statistical tools to compare effects and performance of the data. In correlation analysis is applied to independent factors. So that is the correlation and regression. Now next concept is the precision and accuracy. So when we performing the statistical tools for repeated measurement analysis, so that time we have to consider or take seriously these two factors, precision or important two factors, precision and accuracy. Typically make these two factors are very important when we performing or analysis of repeated measurement of data. So we have to know the precision and accuracy. So typically make the repeated measurement of quantity to ensure quality of their findings, to know the both precision and accuracy of their results. So measurements are said to be precise if the yield are very similar. The results when repeated in the same time. And second one, a measurement is considered accurate if the yields a result that is very close to the true value or accepted. So precise means number of repeated measurements or observations. It is gathered together, that time we have to say that it is precise. But when the number of observation is closely to the expected or standard value, then we have to say that data is very accurate. Now, precise value agree with each other and accurate value agree with true values. So, see the some diagrams. So, we have to clear the concept of precision and accuracy. We have to already discuss in a sensors precision and accuracy. So, first diagram, see the number of observation is closely gathered in near about expected values, and they are closely each other. So that's why first diagram it is the high accuracy and high precision. Second diagram, the number of observations are far from a expected values, but they are closely each other. So that's why there is the low accuracy and high precision. And third diagram, the number of observations are Some are near about expected value, but some are far from expected value, and all the observation not close to each other. So that's why we have to say that there is the low accuracy and low precision. Now we have to require elementary data fitting for this repeated data. So elementary data fitting of the repeated measurement of a variable. So the aim of distribution elementary data fitting is to predict the probability or hypothesis in a set. There are many probability distribution. See list of probability distribution of which some can be fitted or more closely to the observed of the data than others, depending on the characteristics of the phenomena and of the distribution. The distribution given a closed fit is supposed to lead to good prediction. In distribution fitting, there are one needs to select a distribution that suits the data. So when we choose for any distribution for data fitting, so for a repeated measure, so we have to see the first what is the probability distribution, how to closely fitting with their observed frequency of the data than others, and depending characteristics of that. So these are the various factors for considered when for applying the repeated measurement for a data. Now we have to see in the various data fitting technique for repeated measurements. First one is the normal or Gaussian distribution. A normal Gaussian or Laplace loss distribution is type of continuous probability distribution for real and random values. So normal or Gaussian distribution when the data fitting is a continuous probability distribution for a true value for random values. Now second one is the binomial distribution. So binomial distribution can be thought of as a simple probability of a success or failure in an experiment or survey that is repeated multiple times. The binomial is a type of distribution that has two possible outcomes. So when the data has only two outcomes, it is the good or bad, or it is not, it is suitable or not suitable. So that time we have to use a binomial distribution. And next one is the Poisson distribution. It is the used for calculating the possibility for an event with average rate of. There is a calculate the possibility for an event with the average rate of values. Now this concept is the signal. So signal is defined as a function of a one or more variable which conveys information on the nature of physical. The signal can be the analog or digital. So signal is the continuous function with respect to time, or it is the varies with some physical parameter or a physical quantity. So signal can be analog or digital. Analog signal can have the infinite number of values in a range. So digital signals can have only limited number of values. In data communication, we are commonly use periodic analog signal and non-periodic digital signal. Periodic analog signal can be classified as simple or composite. Simple periodic analog signal or composite periodic analog signal. So simple periodic analog signal, a sine wave, cannot be decomposed into a simpler signal. So we cannot easily convert it into a simple signal. So a composite periodic analog signal is composed of multiple sine waves. Composite periodic signal is the combination of multiple sine waves. So signal, periodic analog signal, is complete pattern with measurable time is called as and repeats that pattern over a subsequent pattern. The completion of one full pattern is called. So a periodic analog signal it repeated their patterns with respect to time. So when it is complete one pattern, that is called the cycle of that periodic elements. And a non-periodic signal changes without exhibiting pattern or cycle if it is over. So both analog and digital. If signal does not change at all, its frequency. So there some no changes in signal. So that time we have to say frequency. If signal changes in instantaneously, its frequency is infinite. Frequency is the rate of change with respect to time. Change in short span of time means frequency. Change over a long span of time means low frequency. Frequency and period are the inverse of each other. So there is the inversely proportional relation between frequency. So T is equal to 1 upon F or F is equal to 1 upon T. Now, periodic composite signal. A composite signal is a combination of simple sine waves with different frequencies, amplitude, and phases. The phase is describes the position of waveform relative to time c. If the composite signal is periodic, the decomposition gives series of signal with discrete frequency. If signal is periodic, so you will get the discrete frequencies of a signal. If the composite signal is non-periodic, the decomposition gives combination of sine waves with a continuous frequency. When a signal is a non-periodic, so you will get the sine waves with a continuous frequency. A complete sine wave in the time domain can be represented by a single spike in the frequency. So one sine wave can show in a time domain from a complete sine wave. We have to convert time domain to frequency. That time in frequency domain you will get the only single spike. The bandwidth of composite signal is the difference between the highest and the lowest frequencies contained in that signal. Now, signal analysis. Signal analysis is done by various mathematical tools. So, signal is divided by two categories. First one is the analog, that is the continuous signal. Second one is the digital signal, that is the called discrete signal. So, analog and continuous signal are again converted into two categories, periodic and non-periodic. So periodic signal analysis by Fourier series, non-periodic signal is analysis by a Fourier transform. In digital signal or discrete signal also periodic and non-periodic subtype. It again there are subtypes. Periodic has the periodic signal is analyzed by discrete Fourier series, and non-periodic signal is analyzed by discrete Fourier transform and Z transform. First tool is the Fourier analysis. Fourier analysis is tool that changes a time domain signal to a frequency domain signal and vice versa. Every composite periodic signal can be represented with a series of sine and cosine functions. The functions are integral harmonics of the fundamental frequency f of the composite signal. Using the series, we can decompose any periodic signal into its harmonics. Fourier transform gives the frequency domain of non-periodic time domain C. Inverse Fourier transform gives time domain of a non-periodic frequency domain C. Signal analysis is done by following components. First one is the filter for sampling of signal, data converter for analog to digital conversion of signal and vice versa. And third one is the digital signal processor for processing of signal using various mathematical tools. So these three main components are used for a signal analysis in signal conditioning circuits. First one is the filter, sampling the signal. Second one is the data converter for ADC and DAC, and third one is the digital signal processor for processing a signal using a various mechanical tools. Now, next concept is the signal to noise ratio. Noise is unwanted signal which interferes with the original signal and corrupts the parameters of the original signal. This noise is produced by the external source which may occur in the medium or channel of communication. Usually this noise cannot be completely eliminated. SN ratio is a measure used for compares the level of a desired signal to the level of background noise level. So SN are defined as the ratio of signal power to the noise power. So we get the mathematical expression S upon N signal to noise ratio is equal to signal power upon noise power. If the higher the value of S and R, then greater will be the quality of the received output. Sources of noise. There are two main ways in which noise is produced. One is through some external source, while the other is created by an internal source within a receiver section. First one is the external source. The noise is produced by the external sources which may occur in the medium or channel Q2. This noise cannot be completely eliminated. The best way is to avoid the noise from affecting the signal. First one is the atmospheric noise due to irregularities in the atmosphere. Second one is the extraterrestrial noise such as solar noise, cosmic noise, and third one is the industrial noise. So these are the noise are affected by a external, or these are the external source which produce a noise at the output. Now second source is the internal source which generates the internal error or internal noise in a system and produce the noise or error at the output. This noise is produced by the components while functioning. The components in the circuits due to continuous functioning may produce few types of noise. This noise is quantifiable. A proper design circuits may lower the effect of the internal noise. First one is the thermal irrigation noise, that is the Johnson or electrical noise. Second one is the short noise due to a random movement of electron and fluids. Third one is the transient time noise during transition. Fourth one is the miscellaneous noise, is another type of noise which includes flickers, resistance effects and mixers generated noise, etc. So these are the internal source of noise which generates the noise or error at the output. So we have to use the various noise reduction techniques. It is often possible to reduce the noise by first one is the controlling the environment condition like as a wind, vibration, the gravitational attraction of the moon, variation of temperature, variation of humidity and etc. Second one is the low noise amplifier for internal circuit noise. Internal circuit, electronic circuit noise. Second one is the third one is the analog or digital filter for easily eliminated noise. And fourth one is to enhance the SNR by averaging the measurements. So we have to increase or enhance the performance of SNR by averaging the measurements. Thank you.